picking back up where we left off, using this metaphor for water and energy, let's use this metaphor for a fluorine atom. Okay, so we're still going to say energy up this way. Okay, being lower energy is more stable. So you guys understand? Does that make sense conceptually? Okay, that when you have a lower energy level, you're actually more stable. So if we have a neutral fluorine atom, so this is a fluorine atom that would like to have one. All right, so we have a neutral fluorine atom. It's got a relatively high energy level. It's not really stable because it needs to gain an electron to become stable. So if we compare that to an F1 minus ion, a fluoride ion, it's got lower energy. So to get away from the rock and the hill and all that stuff, it actually has less energy. So this difference in energy is considered the electron affinity. Now, it's a negative number because this is lower. Okay? So if we think about it, and you guys, and if you were in physics, this would make perfect sense. If we think about it as a change in position, if this number is 100, I'm making up numbers, these mean nothing. And this number is 10. What do you have to add to 100 to get 10? Negative 90. So this electron affinity, this amount of energy, is negative. Does that make sense?
I thought if it's a negative 1 ion, it means it gains an electron.
Right.
So would it have more energy?
No, because it's more stable.
I thought less energy was stable.
Wait. Less energy is more stable. It is more stable. It has less energy. So the neutral fluoride atom had this much energy. The fluoride ion has this lower level of energy. It is more stable. The difference between these two energy levels is in essence a negative number. Does that make sense? Did I misspeak something, or because I'm?
No, the part where if it's gained an electron, I just thought it would have more energy. I don't necessarily understand that part.
Okay, it depends on the atom that you're starting with. So fluorine is more stable, lower energy when it gains an electron. Sodium, if you try to add an electron to sodium, it's less stable. So it depends on the atom. This is very much like, again, with the chocolate chip cookies versus the raisin oatmeal. It depends on the individual. So what you have to look at is, does adding an electron bring it closer to the perfectly stable configuration, which is what? Noble gas. Noble gas. Remember, noble gas is the perfect, it is the ultimate in stability. Does adding an electron make it more like a noble gas or less like a noble gas? So for fluorine, and we haven't done these yet, but you probably did them in physical science. Do you remember what that's called? Lewis dot diagram. Neon, the nearest noble gas to fluorine. All the noble gases have a full complement of 8 valence electrons. Does adding an electron make it more like this or less like this? So for fluorine, if we add an electron, it looks exactly like that. It's way stable. Its energy level is dropped significantly because it's very stable. Now, if we took, let me copy this. Let's go to the next page. Paste it. If we took sodium, which looks like this, and we added an electron, does it look more like a noble gas or less? Less. Because if we So for sodium, to achieve noble gas status, remember that sodium is actually neon plus 3s1. It wants to get rid of that, and then it looks just like neon. If we add another electron to this, what we're doing is we're making sodium now neon plus 3s2. So it's becoming less like the noble gas that it's easiest for it to emulate. Does that make sense? Okay. So then, looking at positive electron affinities, cut. If we have a neutral atom of sodium, so this is Na with one valence electron.